Alright, the LED flasher flowchart is is a visual representation of what the software will be doing throughout uh, its active time. And it's very simple. The first thing is it configures the LED output pin. You don't know how to configure LED output pin yet, but you will learn how to do it in a couple of videos ahead. It starts at the off state. It's very important you start at the off state for everything because if you start at the on state, the LED will be on at start, but we want it to be off at start, so we have to start it at the off state, and there's a way we do that. You'll be seeing that in the video ahead. The next thing is this flowchart goes from top to down. So the next step is to turn on the LED. After turning on the LED, there is a code to do this, but we're not focusing on the code for now. We're just focusing on what is happening for now. So it turns on the LED. After that, it delays for 2 seconds for us to see that the LED has come on. Let me tell you something very funny about microcontrollers. If you don't delay, if you don't tell it to wait for you to see the LED on, it will, once it turns on the LED, to quickly go and turn it off, and it does it so fast. Imagine it executes about 4 million instructions in 1 second. So as soon as it turns on the LED, if it does not see any delay, it will just go and turn it off, and you will never see the LED on. The LED will be constantly off to you, but to the microcontroller is actually doing what you told it. It's actually turning on the LED and turning it off, but it's doing it so fast that at the end of the day you don't even see the LED come on. So that's why the delay is very important for us humans to be able to see that yes, the LED actually came on. After that delay, it will turn off the LED, and then delay again for us to see that the LED has gone off, because if it does not delay, it will do everything so fast and you will not just see anything happening. You will miss the show. So if you want to really enjoy the show, you need to slow the microcontroller down with all these delays. Alright, but after it delays for 2 seconds, should it just go and rest? Because if it delays for 2 seconds and program ends, it means that the LED will actually come on once, go off, and that's the end of the party. But we don't want that. We want it to continue happening till infinity. So to do that, we don't send it to go and rest. We don't end the program. Instead, we take it back to square one, according to what people say. It goes back to square one and re-execute this thing again, and follows the arrow, goes back again, execute this thing again, goes back to the same place. It doesn't execute all these ones again. All these ones are just once, execute them once. But these four stages are done repeatedly over and over and over and over and over again, and this act of doing over and over again is called a loop. So it loops through this stage till we remove the power from the microcontroller, and you're going to see how to create loops in the next video ahead, where you'll be learning about how to write the program. So this loop is very, very important. It is this loop that makes your phone always respond to you when you want it. If your phone did not have a loop, you will press the phone and to just ignore you. So the phone is always looping, checking whether you have pressed the sleep or wake button, so that anytime you press the wake button, it will answer you and light up the screen and welcome you. If there was no looping function in programming, you will not be able to, that everything you see today will be impossible. So the loop is very, very important. So let's see how the program